Understanding the electrical requirements for split-system heating, ventilation, and air conditioning, or HVAC, systems is essential for safe and code-compliant installations. A split system typically consists of an indoor unit, such as a furnace within a coil evaporator, and an outdoor unit, which is usually a condensing unit. The question of whether both the indoor and outdoor portions of a split system require dedicated outlets is a common one. The National Electrical Code, or NEC, provides guidelines for electrical installations, and it is important to consult the latest edition of the NEC and local codes to determine the specific requirements in your area. Outlets, also known as receptacles, are points in an electrical wiring system where devices can be connected to the power supply. The NEC addresses the placement and requirements for outlets in various locations, including those serving HVAC equipment. Generally, HVAC equipment requires a dedicated circuit. This means that the equipment should be supplied by a circuit breaker in the electrical panel that is exclusively for that piece of equipment. This is to ensure that the HVAC system receives the necessary power without overloading the circuit. As for whether both the indoor and outdoor units require dedicated outlets, the answer is not always straightforward and can depend on several factors. Firstly, consider the electrical connections of the equipment. Some HVAC units are designed to be hardwired directly to the electrical system. This means that the wires from the unit are connected directly to the circuit breaker or a junction box without the use of a plug-in outlet. In this case, an outlet is not required. Secondly, if the HVAC unit is designed to be plugged into an outlet, the NEC specifies requirements for the type and location of the outlet. For example, the NEC requires that outlets installed outdoors be weather-resistant and protected from the elements. Ground fault circuit interrupter, or GFCI, protection is often required for outdoor outlets, as well as outlets in damp or wet locations. The purpose of a GFCI is to protect people from electric shock by detecting ground faults and interrupting the circuit quickly. Thirdly, the NEC also addresses the accessibility of outlets. The NEC requires that outlets be readily accessible, meaning that they should not be obstructed or difficult to reach. This is to allow for easy disconnection of the equipment for maintenance or repair. In the case of a split system, the indoor unit and outdoor unit may have different electrical connection requirements. The indoor unit, such as a furnace within a coil evaporator, may be hardwired or plugged into an outlet depending on the design of the equipment and local codes. The outdoor unit, such as a condensing unit, is often hardwired due to its high power requirements and exposure to the elements. However, some smaller condensing units may be designed to be plugged into an outlet. It is important to consult the manufacturer's instructions for the specific HVAC equipment being installed. The manufacturer's instructions will specify the electrical connection requirements, including whether an outlet is required and the type of outlet that should be used. In addition to the NEC and manufacturer's instructions, local codes may also have specific requirements for outlets serving HVAC equipment. Local codes may be more stringent than the NEC and may require additional safety measures or specific types of outlets. It is important to check with the local building department or electrical inspector to determine the applicable codes in your area. When installing outlets for HVAC equipment, it is important to follow all applicable codes and safety guidelines. This includes using the correct wire size, circuit breaker size, and outlet type. It also includes properly grounding the equipment to prevent electric shock. Grounding is the process of connecting the metal parts of the equipment to the earth, providing a path for fault current to flow back to the source. This helps to protect people from electric shock in the event of a ground fault. It is recommended that a qualified electrician be hired to install or modify electrical wiring for HVAC equipment. A qualified electrician has the knowledge and experience to ensure that the installation is safe and code compliant. They can also help to determine the specific outlet requirements for the equipment being installed. In summary, the question of whether both the indoor and outdoor portions of a split system require dedicated outlets depends on several factors, including the design of the equipment, the NEC, manufacturer's instructions, and local codes. Some HVAC units are designed to be hardwired directly to the electrical system, in which case an outlet is not required. If the unit is designed to be plugged into an outlet, the NEC specifies requirements for the type and location of the outlet. It is important to consult the manufacturer's instructions and local codes to determine the specific requirements in your area. It is also recommended that a qualified electrician be hired to install or modify electrical wiring for HVAC equipment. Understanding the electrical requirements for split systems is essential for safe and code-compliant installations. By following the NEC, manufacturer's instructions, and local codes, you can ensure that the equipment is properly installed and operates safely. When dealing with electrical systems, it is always best to err on the side of caution and consult with a qualified professional. They can provide guidance and ensure that the installation is done correctly. For instance, let's delve into the specifics of outlet requirements based on the National Electrical Code, or NEC, and standard HVAC practices. Firstly, considering the indoor unit, typically a furnace paired within a coil evaporator, is crucial to determine the unit's power consumption. Smaller furnaces often require a standard 120 volts outlet on a dedicated 15 amps or 20 amp circuit. However, larger units, especially those with higher electrical demands, may necessitate a 240 volts connection, either through a dedicated outlet or direct hardwiring. Direct hardwiring involves connecting the furnace directly to the electrical panel via a conduit, bypassing the need for an outlet. This is often the preferred method for larger appliances due to its enhanced safety and reduced risk of accidental disconnection. Secondly, examining the outdoor condensing unit. The electrical requirements vary significantly based on its size and cooling capacity. Smaller units might operate on 120 volts and utilize a standard outlet, while larger units invariably demand a 240 volts connection. Similar to the indoor unit, the outdoor unit can be connected via an outlet or hardwired. Given the exposure to outdoor elements, any outdoor outlet must be weather resistant and GFCI protected to mitigate the risk of electrical shock. The NEC Article 210.8 provides detailed guidelines on GFCI protection requirements in various locations, including outdoor areas. Thirdly, it's imperative to consult the manufacturer's specifications for both the indoor and outdoor units. These specifications outline the precise voltage, amperage, and circuit requirements. The manufacturer's documentation will explicitly state whether an outlet is required or if direct hardwiring is the recommended connection method. Ignoring these specifications can lead to improper installation, potential equipment damage, and safety hazards. For example, if the manufacturer specifies a dedicated 30 amp circuit for the condensing unit, using a 20 amp circuit would result in frequent circuit breaker trips and potential overheating. Additionally, adhering to the NEC is non-negotiable. The NEC provides comprehensive guidelines for electrical installations, including wiring methods, overcurrent protection, and grounding requirements. Article 440 specifically addresses air conditioning and refrigeration equipment, outlining the necessary safety measures and installation standards. The NEC mandates that all electrical work be performed by qualified electricians who possess the necessary knowledge and expertise to ensure compliance with the code. Furthermore, local building codes and regulations may impose additional requirements beyond the NEC. These local codes often reflect specific regional considerations, such as extreme weather conditions or unique building characteristics. It's essential to consult with local authorities to ascertain any supplemental regulations that may apply to the HVAC installation. For instance, some jurisdictions may require a disconnect switch to be installed within sight of the outdoor condensing unit. This switch allows for easy shut-off of power during maintenance or emergencies. When installing outlets for HVAC equipment, several factors must be considered to ensure safety and compliance. Firstly, the outlet must be of the correct voltage and amperage rating for the equipment being served. Using an undersized outlet can lead to overheating and potential fire hazards. Secondly, the outlet must be properly grounded to protect against electrical shock. Grounding involves connecting the metal parts of the equipment to the earth, providing a path for fault current to flow back to the source. Thirdly, the outlet must be located in a readily accessible location, as mandated by the NEC. This allows for easy disconnection of the equipment for maintenance or repair. For outdoor outlets, weather resistance and GFCI protection are paramount. Weather-resistant outlets are designed to withstand exposure to rain, snow, and other environmental elements. GFCI protection is required to prevent electrical shock in damp or wet locations. A GFCI monitors the current flowing through a circuit and interrupts the power supply if it detects a ground fault. This can happen when electricity leaks from the circuit to ground, such as when someone touches a live wire while standing on a wet surface. The GFCI trips the circuit within milliseconds, preventing serious injury or death. In summary, determining whether a split system requires outlets at both the indoor and outdoor portions depends on various factors, including the equipment's electrical requirements, manufacturer's specifications, the NEC, and local building codes. Consulting with a qualified electrician is highly recommended to ensure a safe and compliant installation. By adhering to these guidelines, homeowners and contractors can ensure the reliable and safe operation of their HVAC systems. When planning an HVAC installation, it is crucial to consider future maintenance and repair needs. Providing easy access to electrical connections can significantly simplify these tasks. For example, installing a disconnect switch near the outdoor condensing unit allows technicians to safely shut off power to the unit without having to access the main electrical panel. Similarly, ensuring that outlets are readily accessible makes it easier to test and troubleshoot the electrical system. It's also important to consider the long-term durability of the electrical components. Using high-quality outlets, wiring, and circuit breakers can help to prevent failures and extend the lifespan of the system. Weather-resistant materials should be used for all outdoor connections to protect against corrosion and environmental damage. Regularly inspecting the electrical system can help to identify potential problems before they escalate into major issues. Look for signs of damage such as cracked or frayed wiring, loose connections, or corroded terminals. Any such issues should be addressed promptly by a qualified electrician. Proper maintenance and care can help to ensure the safe and reliable operation of the HVAC system for years to come. Moreover, integrating smart home technology with HVAC systems is becoming increasingly popular. Smart thermostats and other devices can be used to remotely control and monitor the system, optimizing energy efficiency and enhancing comfort. These devices often require additional electrical connections, so it's important to plan for these needs during the initial installation. Consider installing additional outlets or running extra wiring to accommodate future upgrades. When selecting electrical components for HVAC systems, it's essential to choose products that are listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. UL listing indicates that the product has been tested and meets established safety standards. Using UL listed products helps to ensure the safety and reliability of the electrical system. It's also important to be aware of potential hazards associated with HVAC systems, such as carbon monoxide poisoning. Carbon monoxide, or CO, is a colorless, odorless gas that can be produced by malfunctioning furnaces and other fuel-burning appliances. CO poisoning can cause serious illness or death. To protect against CO poisoning, install CO detectors in the home and ensure that all fuel-burning appliances are properly maintained. Regularly inspect the venting system for any signs of blockage or damage. The NEC Article 547 provides safety guidelines. In addition to electrical safety, it's also important to consider the environmental impact of HVAC systems. Older systems often use refrigerants that are harmful to the ozone layer. When replacing an old system, choose a newer model that uses environmentally friendly refrigerants. Also, consider installing energy-efficient equipment to reduce energy consumption and lower utility bills. Energy-efficient HVAC systems can significantly reduce the carbon footprint of a home. Government rebates and tax credits are often available for energy-efficient upgrades. Research and take advantage of these incentives to save money and help protect the environment. When planning an HVAC installation, it's important to work with qualified professionals who have the necessary knowledge and expertise to ensure a safe and compliant installation. Choose a licensed and insured HVAC contractor and electrician. Ask for references and check their credentials. A reputable contractor will be able to assess your needs, recommend the best equipment for your home, and ensure that the installation is done correctly. They will also be able to provide ongoing maintenance and support to keep your system running smoothly. In conclusion, understanding the electrical requirements for split system HVAC systems is essential for safety, compliance, and efficiency. By following the NEC manufacturer's specifications and local building codes, homeowners and contractors can ensure that their HVAC systems are installed and operated safely and reliably. Consulting with qualified professionals is highly recommended to ensure a successful installation. Remember to prioritize safety and always err on the side of caution when dealing with electrical systems. Properly installed and maintained HVAC systems can provide years of comfort and energy savings.